So we've isolated more than this now, but we've definitely gotten all of the major alkaloids out of the plant, and we've gotten many of the minor alkaloids out as well. And we've learned a tremendous amount about these. We've been able to have the luxury of screening each of these compounds through Eurofins 82 CNS drug target panel, and we've learned a lot. And I'll share a couple of those with you, but not all of them as we go through this. I've grouped these compounds more or less, these 12 over here that are naturally occurring in the plant, and then the 3 on the right side of the screen are ones we've synthesized to have in large enough quantity. 7-hydroxymitragynine, the one at the top right of the screen, is the one that's attracted the second most amount of attention besides mitragynine. We do know that it is a metabolite. It is a metabolite that can be formed in the intestine and in the liver. I'll show you a little data on that. And we also know that it can be formed upon drying of the leaves. So we do not believe that it actually exists in the tree in fresh leaf samples from not only our growings, but the harvests and collaborations that we've had in Malaysia. We've not detected 7-hydroxymitragynine in fresh leaf material. That becomes important a little bit later on. And then mitragynine pseudoindoxyl at the bottom right-hand corner was actually first reported as a fungal isolate and a very potent mu-opioid agonist. We wanted to synthesize that. You can synthesize that from the 7-hydroxy compound through a semi-pinnacle rearrangement. And we can now afford that in large enough materials and quantities to study, as well as some of our collaborators or competitors have been doing. But I mentioned earlier, you can see in all of these molecules, we have this beta-methoxyacrylate structure, and the plant is producing these for some reason. And it may be to benefit the plant. It's probably not to benefit humans. So we've been looking at some of that and understanding what might be going on there. And I won't go into details in that just because of time. If you look at mitragynine, the major compound, through the Eurofin screen at 10 micromolar, it only hits at these targets. And interestingly enough, they're serotonergic, alpha-adrenergic, dopaminergic, and opioidergic, along with the dreaded hERG channel. And that's it, 10 micromolar. If we take those hits where we've displaced 50% of the radioligand and go down to the secondary screen at 100 nanomolar, this compound looks very benign. It doesn't seem to interact with any target. We did go and calculate out full Ki values at all these targets. I'm only going to show you the opioid and alpha-adrenergic here. And it's not spectacular. I mean, the Ki value at mu is 136, kappa 157. It doesn't bind to delta. And it's micromolar affinity at adrenergic receptors. It does have partial agonist effect at the mu opioid as well as the alpha-1 and alpha-D adrenergic receptors. We do have some in vivo evidence to suggest that it has alpha-2 activity, agonist activity as well, and that's through drug discrimination, which I don't have time to show you today either. But interestingly enough, if you look at poison control center data, kratom overdoses resemble stimulants, not opioids. So they look much more like a stimulant overdose, a cocaine overdose. There is not the respiratory depression that you would expect as a frequent call-in for poison control centers, or some of the other issues that you might see with opiate overdose.